All right, we're looking at piecewise functions is our topic here in this video. Piecewise functions are just functions that are created with different functions, more than one. So they'll look a little jagged and look a little bit different because we've got different ones. So for example, right here, this is made up of three different functions here. They're all linear on this one, but they don't necessarily all have to be linear. But we've got part of this line that would continue, but we're going to restrict where we want it to be. We're going to restrict its domain. And then we've got this other line as well. That's a whole different equation, and then we've got another equation right here for this one as well. So what we want to be able to do is a couple things: be able to understand what this notation is telling us, and then be able to find its domain from this as well. So what this is telling me is to use this top function whenever x is greater than 0. So I only want the part that is greater than 0 for this. So if I looked at a graph here, I know this is a quadratic function that's been shifted up 3. And again, if you need to plug in 0, because that's a good critical value, you can plug 0 in for that, and that's going to give you 3. But really what this function is, again, is just a quadratic, like so. But what I want is only the part that's greater than 0. So I only want this part here to the right because that's greater than 0 if I'm looking at the x-axis, because that's what that's telling me. Okay, and so for this one, essentially what I'm going to do is I'm going to get rid of this piece right here. I do not want this piece anymore. The other thing that's really important is we got to look at whether or not it's equal to right here. In this case, it's not equal to. Whenever there's not equal to, we're going to use an open circle. And I know there's a lot of stuff going on right there, but I'll try to make that as big as I can there. So that's an open circle there with this part of my quadratic. That's that part. Once I've graphed that part, I'm going to look at this next one. It's telling me that I use 2x plus 4 for anything less than or equal to 0. So this should be over here on this left side of my graph. You just got to remember how to graph linears. For linears, remember this is my intercept right here. This is where it's telling me where it crosses the x-axis. I'm going to do this in red here. So I've got to go up here to 4, and I'm going to put a point here at 4. And then use this as my slope where I'd go up to the right 1. But I don't want to be over here, so I'm going to go the opposite way, which should be down here. So I'm going to go down 2 over 1. And then I can go down 2 again over 1. So this part is here, and I'm going to stop right there because I don't want this. I don't want this part here. Okay, I don't need that part at all. This does keep going this way. And that would be the graph of this piecewise functions. It's made up of two different parts. Okay. If I was to state its domain, well, the domain I can do it a couple different ways. It's telling me what the domain is right here. Or you can look at the graph like you guys have done before. If I look at the graph, it's going, my domain's my x-axis, or my x values. So from left to right, it's moving left forever, so I'd say negative infinity. And then we got to look here. Because this is filled in because it's equal to, then it's defined here at 0, and then it just keeps going. So that would be negative infinity to infinity. The other way to probably look at this would be right here on this. If you notice, this is going greater than 0, this is going less than or equal to 0. So it's covering all x values. When it's covering all x values, it's just negative infinity to infinity. So want to be able to find those domains as well. If you want to find the range, we got to look at the graph here. The graph for my range, or my range for my graph, is just going to be my y value. So that's going to be negative infinity because it's going down forever. And then there is a gap here, but it's defined on either sides. So it just keeps on rolling up, and so we're going to say to infinity here. Okay, there might be some questions where you have to evaluate, like if it says, hey, what's f at negative 2? Or what is f at, let's say, at 0? all you've got to do, remember, this is my x value, I want to know my y value. So if I go -2 in the x, where's my y? It's at 0 here. And for f at 0, because it's not this open circle, it's this filled, or it's filled in circle, we're going to be at 4 up there. Okay. If it gives you something that's kind of like out here, let's say it's like f at like 5. Well, my 5's right here, and I don't have that graphed up here, right? But which function does that take up? It takes up this top one. So just plug in 5 for x here. So we'll go 5 squared plus 3, and that will tell me my y value. So that's another way to look at it that way. So 5 squared is 25, plus 3 is 28. So this would be 28. And that's the other thing they might want you to do, is be able to evaluate those functions as well. Okay? Let's look at another example here. Okay, so this one's got 3 functions. No problems. We can still graph this. No problem at all here. So we're gonna go put these values on here first, so we've got everything we need. Okay, so let's just start with the top one. We'll do this one in red. This is just f of x equals 5, so that means that we've got ourselves just a flat horizontal line for everything less than or equal to -2. So I'm going to go to -2, and then I'm going to go up to 5. 1, 2, 3, 4, 5 up here. And I'm going to put a filled in dot because of the equals to, and then we want to go less than. Well, this is just a horizontal line, but I only want everything to the left or less than -2. So that's that first line. Again, I don't want anything to the right because it's telling me my domain for that one. This second one here is a quadratic. It's been shifted down 2, so this usually is right here, but it's down 2 here. And I would just plug in these values to see where the y is. So I'd plug in -2. When I plug in -2 here, so -2 squared minus 2, that's going to give me 4 minus 2, which is 2. So we know that when it's -2, it's at 2 here. And this is going to be an open circle here. So this is going to come down around, and then it's going to go up here somewhere. We're going to also plug in 2. Well, when I plug in 2, it gives me the same value. And then this is one's equal to, so I'm going to go a filled in dot. So this should look like a U, but we don't keep going because it's telling us we only go from -2 to 2. Okay? And then my last function here, just x, that's a linear. This is just, it goes through the origin at 0, and my rise over run is 1 over 1. So it would be here, and we go up 1 over 1, up 1 over 1. But we want to start here at 2, so I'm going to go here, and then we're going to go up 1 over 1, up 1 over 1, and it's just going to be this straight line. Now you might ask, do I need to put an open circle here? Well, I don't, because it's just connecting to a closed-in circle, so we're gonna roll with it there. I don't necessarily need to put that there because they connect. You can see sometimes they do, sometimes they don't. Okay, so there is my function. Again, if I wanted my domain here, I can look at up here. The nice thing about here is this is telling me less than. It covers everything in between -2 and 2 and more than 2. So my domain for this should be -infinity. Whoops, that's a terrible -infinity to infinity. And then if you want the range here, we've got to look at the graph that I just sketched. The range is down here at -2, and I'm going to use a bracket because it is equal to. And then because of this line, it just keeps going up, and it covers all the gaps here. We'd say to infinity here. Okay, and then again, if you wanted to say, well, what is like f at -5? Well, you go over here to -5. It's at 5. What is f at, let's say 7? 7's way over here. I don't have it actually plotted, but that uses this function. So if I plug in 7 for that, it's going to give me 7, and so on and so forth. If I said like f at 0, that's right here when my graph's here at -2. So you can answer questions like that all day. So All right, one more I want to show you is this one because of this middle function here. So again, let's graph this. If I can draw a not crooked y-axis so bad. There we go. Okay, so we're going to take that top function. That top function is a cubic, and I want everything less than -2. So again, I would plug in -2 there. So -2, that would give me -2 plus 4 cubed. That's going to give me 2. And then when I cube it, it's going to give me 8. So at -2, it's going to be all the way over here to 8. So let's see, 1, 2, 3, 4, 5, 6, 7. Of course, I wouldn't put 8 there, but that point right there. And we're going to do, one thing I've got to make sure I fix here is I've got to do an open circle here, okay? And I want everything less than that. Here's how this would actually look. Remember, this cubic's like this little curved line here that goes up and down here, but we've shifted it forward to the right. So this actually is here. It's dropping down like this, and then this function goes up, and then it just is going to stop right there instead of having that arrow on the end is what it looks like. Okay? So everything less than 2. This next part, this is why I have this. This is -10 when it's equal. So this is just a dot when it says it's equal to. Okay? Because I'm not moving anywhere less than or greater than like I did here. We had everything less than -2, but this one's just because it's equal to, it's just 1 point at -10. So I've got to have a dot from -2, and then we're around here at -10, and this is going to be the filled in, and that's because it's not defined up here. So it's just a single dot here, okay? And then the last one is this function right here. Is a quadratic, everything greater than -2. So I need to figure out what I get for my y value when I plug in -2. So I'm going to go -2 squared plus 8 times -2 minus 1. That just tells me where to put my point before I start sketching this. So again, I get 4 minus 16 minus 1. And so we would get -12, -13 is what we get here. So we're actually going to start even lower down here. I'm not going to put those marks, but we're going to have a point right here that's going to be open again. And then I just need to make sure, let's see, this quadratic, this one's a little bit tougher, but again, I won't have you do anything quite this well, but what I would do is I would look at, like you can plug in some other points. If I plug in -1 here, just to see where these go. So -1 plus 8 times -1. We're just plotting points is all we're doing. So 1 minus 8 minus 1. So we get that at -8. So at -1, we're at -8. Right there. And then if I plug in 0, I'm at -1. So this line is just climbing up here is what it's doing, and it's going to keep going forever. It's kind of, this one's kind of a funny looking graph here. Part of the reason why I had this up here is when you guys go to write your domain, again, you can look here. This is everything left of -2, right of -2, and then it's this value right here that's equal to -2. So technically this is still -infinity to infinity, okay? If for some reason, let's say we didn't have this bottom function at all and it was just everything here, we would go from -infinity to -2, and then we'd have to use our squiggly brackets for -2 if we didn't have this blue line here. But that is where my domain is for that. So, okay. Awesome. The last thing is just to kind of be able to write these equations. And this one's just to look at our equations here. So I'm going to look at this one right here. This is just lines. These are nice. My intercept is at 1, and then it goes up 1 over 1. So this would just be x plus 1 because my slope's up 1 over 1 and then it starts at 1. And that's for x less than 0. And then we'd say equal to as well because we got ourselves a filled-in circle. For this middle line, this one's got a negative slope. We're going down, let's see, down 3 over 1. So if I'm going down 3 over 1, that's going to be negative 3x and then plus 1 because that's where I still cross the intercept here. And that's for everything between 0 and 1 is what that's between. If you look, oops, need that one. And then our last one here, I've got to kind of see where this is going to cross, but I need to know how much it moves to see where this thing crosses here. So up 1, over 1, it like goes a half away. So to get a full, I've got to go up 2 over 1. So this is actually going to go down here. If I think about this, is going to go down 2 more before it crosses here. If I look at this line, it's going to keep going here at negative 4. That just tells me where my y-intercept is. Again, I'm going up 2 over 1. So that's going to be 2x minus 4 is going to be the actual equation I want. And that's for everything x that's greater than or equal to 1 is what that's going to be. So that's how you write your equations there. All right, this has been your math moment with your mom. Audio.